All right, this is Obeid on behalf of V Electronics, and in this video, we're going to be talking about central limit theorem. Now, this is an important theory, an important distribution, whatever you want to call it. But at the end of the day, it has many applications. Okay, application number one is quality control, for example, in manufacturing. Application number two would be surveys and polling in elections. Application number three would be financial analysis. Okay, scientific research is another application. Okay, population estimation is another application. And this is especially useful for business when you're trying to figure out your cost, your gross profit, and your net profit. All right, so let's start off with central limit theorem, okay, which is also called CLT in a short form. So this is CLT, CLT. This is your central limit theorem. All right, and again, very useful, multiple applications in real life. It's not just a theory. Okay, such as quality control, so QC, okay, financial analysis. So we talked about gross profit, net profit, cost. Okay, if you can figure out the probability of something using central limit theorem, you'll know exactly how many units you need to buy for you to restock and for you to make sure that you will have enough units, okay, when you want to sell these units to your customer. Okay, so this will be financial analysis. Okay, you have surveys. This could be customer satisfaction survey, it could be your employee satisfaction survey, it could be survey for the election, it could be survey for a product. Okay, so product satisfaction survey, it could be elections, okay, so on and so forth. Now, there are two forms of central limit theorem, and both have to do with taking a limited number of units as a sample from the population. Okay, so this is limited number of units, and this is also called your sample. So the idea is if we collect sample with a large enough n stands for sample size. Okay, so n, this is number of units in a sample, so this has to do with sample size. So the idea is if we collect large enough, and the reason why they say large enough is to make sure that your sample represents the population as close as possible. Because if you take a small sample, there might be too large of a variation in your mean and your deviation. Okay, there might be too large of a variation in terms of whatever results you get from that sample. All right. So if we take a large enough sample, let's say more than 30 units, Okay, let's say more than 30 units. The sample mean of each sample. Okay, and when we say sample mean, we're talking about the average, which is also represented by this letter over here, this symbol over here. Okay, so sample mean of each sample will follow a bell-shaped curve. All right, and the bell-shaped curve looks something like this. Okay, this is your bell-shaped curve. All right, so if we take the sample mean of each sample, it will follow this bell-shaped curve over here. And the bell-shaped curve also represents normal distribution. So this is normal distribution. And that's the reason why we use the function relevant to normal distribution on your TI-84, which we're not going to talk about in this video. So this is your normal distribution. So if you take a large enough sample, a large enough n, okay, and figure out the sample mean of each sample. Okay, let's say you take 50 samples, okay, and let's say the mean of each sample is as follows. So let's say 2, 4, 5, 3, okay, so on and so forth. So these numbers over here, okay, these are your mean of each sample, okay, and the sample could be 35 units, it could be 50 units. So this is n could be 35, it could be 50, it could be 55, so on and so forth, up till infinity. All right, so your mean, the sample mean of each sample will follow a bell-shaped curve, which is also your normal distribution over here. Likewise, if you take a large enough sample, if we take a large enough sample, okay, and figure out the sum of these samples, okay, figure out the sum of the sample, it will again follow a bell-shaped curve. All right, so let's say this is your bell shape, looks like a bell. And again, this has to do with normal distribution. All right, so the symbol over here is very important when it comes to central limit theorem. Now, even though we figure out probability of landing on a certain value, we also figure out standard deviation. We figure out percentiles, which has to do with area. Okay, so on and so forth. This symbol over here, which represents mean or average, is one reason why people use central limit theorem to figure out the mean. And the application of this mean is comparison. Okay, the main reason why people figure out the mean is to compare. Okay, we know that we can compare certain values using a mean and a median. Okay, and mean is one such value to make a comparison. All right, and you also want to make sure that the sample size is more than 30, for example, because otherwise you'll have to make more observations. You'll have to get more samples. Okay, more experiments. Okay, for you to land as close as possible to your population mean and your population deviation, for example. Okay, discrepancies between the observations that you make for each sample. All right, so that would be it for this video. On behalf of B Electronics, this is Ubay. Have yourself a great day.